Hi all, so today I'm going to be doing the Junior Certificate 2019 Maths paper. It's the higher level paper 1 and we're just going to be doing it from last year's paper. I'm going to walk you through all the answers. Yeah, so hopefully it all makes sense. I will add a link into the bio of this so that you can get access to the paper itself. But with that in mind, we'll get started. So I have question 1 and question 2 up, but we'll focus on the left-hand side first. So the first question we're told is there are 85 students in 3rd year in Liam School. So what we know there is that there are 85 students. Okay. So we know that 2/5 of those students do business studies. Okay, so 2/5 is equal to 4/10, which is the same as 40%. So 40% of the students do business studies. Work out the number of these students who do not do business studies. So what we're being asked to is how many students do not do business studies. So 40% of the students do it. That means 60% do not do business studies. So what I need to do there is I need to multiply my 85 by 0.6. So 1 would be 100%, 0.6 is 60%, and 0.4 would be 40% if we were looking for 40. But obviously we're looking for 60, so we multiply 85 by 0.6, and that is equal to 51. And that's that question done. So 26% of the students in 3rd year do art. Work out the percentage of students in 3rd year who do art correct to 1 decimal place. So we're looking for the amount of students who do art. Now, in total, the amount of students completely is obviously 85/85. So we're just looking for the amount that do art, which is the 26 over the total number. Okay? And with that, we end up getting 0.3058. Now, just like I said before, 0.6 is equal to 60%. 0.3058 is 30.58%. And we're asked to what part of the percentage correct to 1 decimal. So that's going to be 30.6%. And that's that question done. All right. The ratio of students to teachers in Liam School was 15:1. Okay, so the ratio was 15. So that means that for every 1 teacher, there were 15 students. Okay, the school hired 1 extra teacher. Okay, that means that the number of teachers is now increased while the students stay the same. Okay, so the students have stayed the same, but the teachers have increased. The number of teachers have increased. The new ratio of teachers to students was A:1. So they've left that ratio the same. Put a tick in the correct box to show which statement is true. Tick 1 box only. Give an example to support your answer. Well, effectively what we have done is if we added a teacher, this number is going to come down. So rather than it being 15, it's probably going to go to 14:1. So as the teacher goes up, that ratio of teachers to students decreases. If the number of students increase, the ratio would get bigger again. So we'll say that there was 20 new students joined the school. Now your ratio might go from 15:1 to 17:1 or whatever. So the number is going to go down. So your ratio is getting smaller as the amount of teachers increases. So we have A:1, and if we had 15:1, if we know that this is getting smaller, now this number is going to be smaller, so it's probably going to be like 13 or 14:1. So A is going to be smaller than 15. And here we have A is greater than 15, A is equal to 15, and A is smaller than 15. So that's your answer. Give an example to support your answer. Well, you could just say, as the number of teachers increases, the ratio goes, ratio gets smaller. So, and if it says give an example, so say there was 15 students only. So if we had just 15 students, the ratio is 15 to 1. But if we had now two teachers, if we keep the teachers ratio at 1, that goes to 7.5. Okay, so that's that done. Next bit, completely different question. Write down the 4 factors of 45 apart from 1 and 45. So we know that factors are basically numbers that when the product of those numbers, when they're put together, they equal this. So 1 by 45 is equal to 45. So we're looking for the other factors of this. So your factors are only ever going to go up to half that number. So you could never have like a factor of 23 higher. Well, you can, but it's easier just to think of it from the other way. So it could be 1, 2 isn't a factor because it doesn't divide in easily. 3 is not a factor. Oh, 3 is a factor because you have 3 multiplied by 15 is equal to 45. So you have 2 factors here. You have 3 and 15. 4 doesn't go in, 5 goes in. So 5 multiplied by 9 is 45. Now you automatically know that there are only 4 factors, but if there was more, you would continue down the same path. So 3, I'll put these in sequential order. So 3, 5, 9, and 15. And that's your answer. N is a whole number bigger than 1. So we know that n is some whole number which is bigger than 1. It has just 2 factors, 1 and n. Okay, so it has only 2 factors, 1 and n. Pick a number in the box to show what name is given to this type of number. So if we have a number, right, and we'll say it's 5. Okay, so if that number only has 2 factors, that means it has a factor of 1 and a factor of 5. Now, if I had to pick 4, for example, that has a factor of 1, a factor of 2, because 2 by 2, and a factor of 4. So that is not relevant to what we have said here. We said n is a whole number. It has just 2 factors, 1 and n. So this is an example of that. And these are prime numbers. So it's an example of a prime number. A composite is the exact opposite of a prime number, just so you know. And the square would be like 9, and then so where it could be, you know, 3 and 3 is 3 multiplied by 3 is 9, etc. So p is a whole number. Apart from 1 and p, the other factor is 7. So work out a value of p. Okay, so we know that it has factors of 1, 7, and n. 1, 7, and p. So these are its factors. So if I think about the numbers that are multiplied by 7, I have 7. That's not going to be 1 because we know it has another factor. 14, that has 2 and 7, so that's not falling into it because I know that apart from 1 and itself, the only other factor is 7. 21 is 3 and 7. 28 is 4 and 7. 35 is 5 and 7. 42 is 6 and 7, but 49 is 7 by 7. So that would be, if I had 1, 7, and 49, it makes sense. So my value P is equal to 49. That's that one done. Write down the other 4 factors of 12k plus 8 apart from 1, 12k plus 8. So it's saying, what are the other factors apart from the first one? So if I take 12k plus 8, I'm trying to find factors of it. So if I divided it by, say, 2, well, if I divide it by 2, I would have one factor of 2, and I would have another factor of 6k plus 4. So that's going to be 2 of my 4 factors, 2 of my other 4 factors. Now, if I divide it by 3, 3 is not really going to go in because it will go into the 12k part, but it won't go into the 8. So if I divide it by 4, that's going to work too, because I'm going to get 4, and I'm going to get 3k plus 2. So there are my factors. So I just write them in. $6k rather. And that's basically all there is to it for those 2 questions. Hope they were pretty clear. In terms of time, you're generally given 5 minutes for this and 10 minutes for this. So I think we're at a pretty good pace so far. Hopefully that you're understanding everything. Okay, the next one is question 3. We're told that the distance between Earth and Mars is 56 million kilometers. Okay, write down the distance in the form A10 n km, where A is a number between 1 and 10, and n is a natural number, meaning it's like 1, 2, 3. It can't be like -1, etc. So these ones are pretty easy as long as you know what to do. So you're going to go 1, 2, 3, 4, 5, 6, 7. So it's going to be 5.6 by 10 to the power of 7 km. And that's it. You just need to be able to do these questions and know how to do them. The diameter of a human hair is roughly 0.0075 centimeters. Write down the diameter in the form b of 10 to the n cm, where b is greater than or equal to 1 and less than 10. Okay, so with these, we need to go this way. 1, 2, 3. So it's going to be 7.5 by 10 to the -3 cm. Yeah, and it's important to make sure your notations are correct. You know, if this was in meters, we would have a very different answer. It would be a lot smaller again. Just make sure that if it does come up, that that your notations are the same and you put them in the right format. Okay. So the next part, we're told that Lewis is driving at 90 kilometers per hour when he sneezed. During this time, his eyes were closed for half a second. Work out how many meters he traveled in this time. So we should know that he traveled 90,000 meters, because 90,000 meters is equal to 90 kilometers. Because in 1 kilometer, we have 1,000 meters, and so 90 of them, we're going to have 90,000 meters. During this time, his eyes were closed for half a second. So he was traveling at 90 kilometers an hour, or 90,000 meters. And every hour we have 60 minutes and 60 seconds. So that's going to give us 3,600 seconds in an hour. So in 1 hour, he travels 90,000 meters in 3,600 seconds. So speed is equal to distance divided by time. So our distance is 90,000. Our time is 3,600. So that is going to go by that. That is going to go into that. And this is going to go 18 and 450. That's going to go 9 and 225. That's going to go 75 and 3. And in fact, it's going to go 25 and 1. So 25 meters per second. So every meter, he travels 25. Every second, he travels 25 meters. So he's traveling 25 meters per second. Now, he closed his eyes for half a second. Okay, so if he closed his eyes for half a second during the sneeze, how many meters did he travel when his eyes were closed? Well, 25 multiplied by 0.5 is going to be 12.5 seconds. So that is your answer to that. Okay, hopefully that's clear. Next one. So the next one, we're told Katie has a gross income of 52,460. 8.5% of this is deducted in pension contributions. The amount that is left is Katie's taxable income. So this is the amount of money that she earns. This is the amount of money that she earns. And we know that 8.5% of this is deducted in pension contributions. The amount that is left is that Katie's taxable income. Work out Katie's taxable income after the pension contributions have been deducted. So we know that she earns 52,460. But she's deducted 8.5% of this. So 100 minus 8.5 is equal to 91.5. So she's left with 91.5%, or multiply this by 0.915, which is equal to 48,090 cents. Just be sure that is a comment in case people think it's a dot. So the amount is left is Katie's taxable income. So that's her taxable income. That's it. Katie pays income tax on her taxable income. So that's her taxable income at a rate of 20% on the first 34,000 and 40% on the balance. She has annual tax credits of 4,200. So we need to find out how much she's actually taxed on each of this amount. So we know that on 20% of 34,000, so she's getting taxed 20% on the first 34,000. So we multiply 34,000 by 0.2. And that figure is going to be 6,800. Now, we know that for the she is taxed 40% on the balance. So whatever's left between this and this is what she gets taxed 40% on. So 48,000 minus 34,000 is equal to 14,000.9. And on that, she gets taxed 40%. So that's going to be 5,600 and 36 cents. So she's getting now taxed 6,800 and 5,636. But we're told that she has annual tax credits of this amount. So she, despite getting taxed this amount, or this is the amount that she's taxable, she doesn't get taxed on 4,200. So we add those together. And then we're going to take away 4,200 from the result. So that's 12,436, and then we take away 4,200 from that. So she is being taxed 8,236 on her full earnings. So we take that amount. So what we're told then, work out Katie's net income. So her net income is going to be her taxable income minus the amount that she gets taxed. So that is 48,000 minus 8,200. So that's going to be a 4, a 5, 0, 0. It's going to be an 8. It's going to be 39,800. So she gets taxed 39,800 on her income. That's her taxable income. Okay, Katie got a credit card bill 3 months ago for 420 euros. So she got a credit card bill for 420 euros. The interest rate on her credit card is 2% per month. So she gets charged an interest rate of 2% per month. And it's compounded monthly. Okay, so that means that every month she's going to get charged 2%. She has not paid off any of her bill. Work out what her bill is now. So the easiest way to do that is just to use your financial calculation. And I'm going to go to the math tables to find that. Yeah, so it's going to be my compound interest. F is equal to P plus I to T. So F is equal to P 1 plus I to T. So our P is going to be 420. Our 1 and then plus our percentage. So it's 0.02. So 0.02 times T, because we know it's been compounded monthly. So that's going to be, we're told it's 3 months. So that's going to be 2 1/3 to the power of 3. And that's going to end up, when you calculate it out, to be 445.71. So you would end up getting 1.02 and getting the cube of it, and then multiplying that value by 420, and you'll end up with this. Katie bought a motorbike last year. Okay, so she bought a motorbike last year. Since she bought it, the motorbike lost 10% of its value. So when she bought it, it was worth, it's lost 10%. So it's gone 10% down since she bought it. The value of the motorbike is now 12,150. So it's currently valued at 12,150. And that value is 90% of the original value. So the easiest thing really to do is to find out what it would have been when it was 1% and then multiply that value by 100. So you divide 12,150, divide it by 90, and multiply it by 100. And that value is going to end up being 13500. So you know that's 90%. You find out what 1% was equal to. So this will give you 1%. And then you multiply that value to get 100%. And this was then her original value. Okay, hopefully that's clear. And the sets A, B, and C are as follows. A is a set of multiples 2, 4, 6, 8, 10, whatever it is. So we can say 6, 8, 10, 12, 14, 16, 18. This is 3, 6, so it's in multiples of 3, so 9, 12, 15, 18, 21, 24, 27, etc. And this is in multiples of 4, so 4, 8, 12, 16, 20, 24, 28, etc., etc. Write down a number that is in A intersection B intersection C. So some number that is in all three. So 2 is not in all three. 4 is in A and C, but it is not in B. And the first one is 12. So we can see 12 is in all of them. So I would just say 12. That's the answer to that. Explain why C is a subset of A. So we know that A is 2, 4, 6, 8, whatever. And C is a subset, 4, 8, 16. So basically every value, so every value from C is in B, is in A. So that's why you can say it's a subset, because they're all to the doubles value. All right, these sets A, B, and C are shown in the Venn diagram. There are 7 regions in the Venn diagram. Fine. Because C is a subset of A, there are 2 regions in the Venn diagram that have no elements. Write an X in each of these 2 regions in the Venn diagram. So if we were just to take multiples of 2 and we look at this, we could imagine that there would be like a 2 here in this. So that would be a region which we can put an X into. If I look into B, 3 is unique to this, so I could imagine having a 3 in here. So that's fine. If I look at C, there should be nothing in C that's not in A, because we already know it's a subset. So any value that we have here, like 4 or 8, they're all going to be in this area, because any value which is in C, which is also A, will be in here. And then we can imagine a value that's in A and B is like 6, 12, 18, that sort of number. So we'd imagine that we're going to have a 6 here. Now we already know that 12 is in all 3, so this, you could imagine a 12 being here. So that means we now have our 2 areas where there's nothing. So that's that. Each of the other 5 regions in the Venn diagram has some elements. In each of these regions in the Venn diagram, write down one of the elements in that region. Well, I've already done it, so that's what you would do. 6, quite a long one now. So we're told that Poppy and Ella ran a 5-kilometer race. The simplified graph shows the time that it took Ella to run D kilometers during the race. So even though it says D, we can see that D is equal to 5 kilometers in total. And the total time is in minutes. So we can see that it looks like it's like 30 minutes or whatever. But we can see that Ella finished the race around 26 minutes. So distance is on the horizontal axis. So for example, it took Ella 26 minutes to run the whole 5K. So we can see that it took her 26 minutes. The table below shows the total time that it took Poppy and Ella to run each of the given distances. Using the figures in the table, draw a graph in the diagram above to show the time it took Poppy to run D kilometers during the race. For D where it's greater than or equal to 0, less than or equal to 5. So we know that for Poppy, we're looking at for here. Now we're told that in the distance in the race in kilometers, it took her this length of time to do the interval. So for the first minute, for the first kilometer, it took her 5 minutes. So our first point is going to be here. Now we're told for the second kilometer, she finished it after 10 minutes. So it's going to be here because it's 2 kilometers after 10 minutes. Next, we're told the total in for Poppy for 3, so for kilometer 3, she finished that in 17 minutes. And we're told that for kilometer 4, she did it in 24. So for kilometer 4, which is kilometer 4 in 24 minutes is here. And for kilometer 5, she finished kilometer 5 in 30 minutes. So here. So we have a graph like this. It's not very straight, but so our graph is going like this, then it takes a slightly bigger angle up, and then the angle gets a bit smaller again as we go down. So using Ella's graph, fill in these 3 missing values in the table below. So we know that after kilometer 1, Ella finished it in 4 minutes. So that's that point. So in kilometer 2, that is 8. So we put 8 there. So after kilometer 3, she finished it here, which is 14. For kilometer 4, she finished it at 20 because it crosses right on that grid line. And we've already found the last one, so we don't need to do that. Show that Poppy's times in the table do not make a quadratic sequence. So in order to do that, we have to find the second difference. So if we're looking for Poppy, it's 5, 10, 17, 24, and 30. So we have to find the second difference. So the difference between these is 5. The difference between these is 7. The difference between these is 7. And the difference between these is 6. So that gives us the first difference, but now we have to find the second difference. So that's 2. Now these should all be sequential for it to be these should all be equal if this is a quadratic sequence. So that one's 2, so the next one would need to be 2. But the difference between 7 and 7 is 0, and the difference between that is 1. So this is not a quadratic sequence. So helpful if you know that for the exam, it obviously can come up. So for this, we are told that it took her 26 minutes to run 5 kilometers. So we need to find the average speed. So give your answers in kilometers per hour, correct, 2 decimal places. So we should know that speed is equal to distance over time. So we're trying to find her average speed. So we know that she ran 5 kilometers in 26 minutes. And then we would need to multiply that by 60 to get it per hour. So we're trying to find the speed per minute. That's the speed per minute. And then we're going to multiply it by 60 minutes. And that value will end up equaling 11.54 kilometers per hour. So again, it's basically just an equation. Speed is equal to distance over time. You then find it for 1 minute and you multiply it for 60 minutes. Take the correct box to show what happened to Ella's time after 2 kilometers. So after 2 kilometers, so she ran the first kilometer in 4 minutes. She ran the second kilometer in 4 minutes. And she ran the third kilometer in 1, 2, so 1, 2, 3, 4, 5, 6. So she ran the second kilometer in 6 minutes. So her speed got slower in the second. So her speed decreased. And the justification is the graph. The justification is the graph starts peaking up. So her distance got, the time it took her to run the kilometer was longer. km 2 to 3 was longer. So the time it took her to run kilometer 2 to 3 was longer. Kieran also ran the 5 kilometer race. He drew the graph below to show the time that it took him to run d kilometers during the race. The part of Kieran's graph C is marked with a vertical line. So what does the part C tell us about Kieran's running at this stage? So if we look at this, we see that this is the distance he was running and this is the speed. Now, if we look at this, if I'm on this line, that means that at all points during this time, I was on the second kilometer. So I was on the second kilometer between time 10 and 15, which means that basically he stopped doing anything. He just stopped where he was. So Kieran did not run during this time. Did not run during this time. And that's basically what you're saying, because he was the speed, the distance that he ran did not increase during that time period. Distance did not increase during that time period. Okay, Brendan says Kira's graph does not show the total time as a function of distance d. Give a reason why Brendan is correct. So for these kind of questions, it's just very important to know what a function is. So a lot of the time we'll say f of x is equal to x squared plus 2x squared plus 4, whatever it is. That means that we say a function of x, but when we say a function of x, we basically mean that this is the same as y. So, basically, if you plugged any value in, so say I'd say 1, I would say my x value was 1. Into that, I would end up getting a y value of 1 plus 2 plus 4 would be 7. So for a value x of 1, I would have a y value of 7, if that was the scenario. That isn't the scenario, I'm just explaining what's going on. So what it's saying here is Kieran's graph does not show total time as a function of distance. Give a reason why he is correct. So this is distance, but if we wanted to show time as a function of distance, it would be basically the other way around. So our distance would be have to going this way. So our distance would be have to. So you could just say here, distance is equal to x axis, hence it is not a function. Okay, hopefully that's clear. If you're not clear on that, I suggest that you follow up in your maths books on a function of x to understand that part. Okay, I'll move on to the next piece. So question 7 and question 8. Describe each of the following sets. Be as specific as possible. So it just says the set of natural numbers. And so this basically just means if you had a number line, so you could say -1, 0, 1, 2, 3. So a natural number is any number here. So this is a natural number. This is a natural number. Natural number, natural number. This is not a natural number. So -1 is not a natural number. But the rest are. So these whole numbers are natural numbers. Next one is a set of integers. So integers is minus values also. So it's basically any whole number, but it can be a minus also. So you could have -2, -1, 0, 1, 2, 3. You have a number line. All of these are integers. But like a half is not an integer. A half would be a rational number. And that's it. Graph the following inequality on the number line. So -3, so x is greater than -3. So you'd have this. And you're told that it's a rational number, a real number. And x is equal to 2. Or x is greater than or equal to 2. So x is on this, so you'd have that as a. So I've drawn a circle here because it's greater than 3. And it's any number in between this. So I'd make that a bit bigger so it's very clear. And this one, you'd have a closed dot. Use algebra to solve the following inequality. So you just say -7, you bring any solid value across. So it's going to be -7 -8 -3g 11 -8. Now I want to get rid of my minuses here, so, but I'll just do the calculation first. So I'm going to get -15 -3g and 3. But I want to turn this minus into a plus, so the signs are all going to change. So that's going to be divide everything by 3, so it's going to be 5g -1, and that's my inequality done. Okay, The next one is the Venn diagram below shows the number of people in a youth club, U, who play music, and sports, S, where N is an element of the natural number. Okay, so work out the maximum number of people who could be in the youth club. So we basically have a Venn diagram, and we have a number of information. So if we just look at the people who play music, so M is equal to 52 plus 184 minus N. So that's a sentence that we're happy enough to write. So just getting rid of the 184, it's going to become 206 minus N. So that's what M is equal to. What is S equal to? So S is equal to 2N plus 184 minus N. So that's going to be 184 plus N. So M is equal to 236 minus N. S is equal to 184 plus N. And we know that 125 people don't do anything. So not in it is equal to 125. So what is the maximum number of people who could be in the youth club? Well, the maximum number of people who could be in the youth club is M plus S plus 0. So we know that in the youth club, U play music, M play sports, and 125 of them don't do either. So the maximum number of people would be this. So it would be 236 plus 184 plus 125 minus N and plus N. So if that was into 0, this would be the maximum. So the maximum would be 545. Now in reality, N is probably equal to some number like 10, but it's looking for the maximum. So we're going to assume that value is 0. So that would be the maximum value. So hopefully that's clear. All right, so question 9 is a pretty long one too. Yeah, so we'll read what it says. So Gertie writes down the following sequence, which repeats every 3 terms. Okay, so you know it repeats every 3 terms. So it's going to be 364, 364, 364, etc., etc. So the first term is 3. Write down the 12th term. So if the first term is 3, the third term is 4, the 6th term is 4, the 9th term is 4, the 12th term is going to be 4. So my ninth term is going to be 4. Because we know that it's, so it's, this one is going to be the 3rd term, this is going to be the 6th term, it's going to be the 9th term, and it's going to be the 12th term. So that's that. Work out the value of the 100th term. So the easiest thing probably to do here is to find out what like the 4th term probably is, and then work your way up from that, because it will be 4, 8, 12, 16, 20, and then obviously because it's in blocks of 20, it's going to go up to 100. So probably the easiest, I mean, you could do it multiple different ways, but I think picking the 4th one is probably the easiest, and then multiplying that out accordingly. So I have 3 as my 4th term, so 3 is going to be my 8th term, it's going to be my 20th term, it's going to be my 100th term. So 3 is going to be my 100th term. You should probably put in some logic, so I would say 3 is the 4th term, 3 is the 20th term, so it will also be the 100th. Again, there's no hard or fast rule on this. It's just the way I've done it because I think it would be easiest in that scenario. Yeah. So for this, we're told to describe how to find the value of the n term of the sequence where n is an element of the natural number without listing all the terms. So we know that the sequence repeats itself every 3 times. So if I was to pick a term, say 21, So n is equal to 21. Well, if I divided 21 by 3, I would equal to 7. So the remainder is going to be 0. So I'm going to be on the third term each time. So so my 21st term is going to be 4. Or yeah. So if I have a 3, if I divide the number by 3 and my remainder is 0, my value is going to be 4. If I had n is 22, well, 22 divided by 3 is going to be 7, remainder 1. So it's going to be like the 4th term or the 7th term. So it's going to be equal to 3. So every time I do that, and then if effectively for 23 divided by 3 would be 7, remainder 2, and your answer is going to be 6. So plugging those values in, you're going to get that. So that's basically showing how you could do it for any term using the division by 3. Okay, the next thing we're told, Gertie made the sequence, her sequence 3, 6, 4 by picking 3 as the first term and then using this rule. So Gertie made her sequence this by this formula she'd done. So she was told if a term is odd, multiplied by 2 to get the next term. So she's told that if the term is odd, she needs to do this. So if, for example, it's even, add 2 to it and half your answer to get the next term. I'll just move all these out of the way. So for example, 3 is an odd number. So 3 is an odd term. So the next term is going to be 2 times 3, which is going to be 6. Fine. So now her term is an even number because 6 is an even number. So now her next term is going to be 6 plus 2. So add 2 to it. And then divide your answer to get the next term. So she gets 6 plus 2 is 8, divides it by 2 to get 4. So she gets 4 then over here. So that's what she has done to do. So a different sequence follows the same rule, but is 8 as the first term. So 8 is an even number. It even tells you how to do the second term. So it says the second term is a half by 8 plus 2. So we have 10 over 2, which is equal to 5. Now, 5 is obviously an odd term. So if the term is odd, multiply it by 2 to get the next. The next term is going to be 10 because 2 times 5 is 10. Using this logic. So 10 is now an even term. So we need to add 2 to it and then divide it by 2. So it's going to be 12 divided by 2, it's going to be 6. So this term is going to be 6. And then we're told that if it's an even term, we need to do the same thing. So it's going to be 6 plus 2 over 2. So it's going to be 8 over 2 is going to be 4. And that's that part done. So Ahmed takes 2 as his first term. Okay, and he uses the same rule. State what's unusual about Ahmed's sequence. So if he uses 2 as his first term, 2 is an even term. So what we need to do is we need to add 2 to it, and then we're going to divide it by 2. So that's going to be 4 divided by 2 is going to be 2. So we'll have the same thing again. So no matter what, we're going to have 2, 2, 2, 2, 2. It might, state what's unusual. So the 2 is repeated. And we've done a few. I mean, there's not need to do that many more. Once you've done the first one, you can pretty quickly realize that the rest are going to be the exact same. In another sequence, so moving up to this, part E, in another sequence using the same rule, the second term is 86. So we know the second term is 86. Work out the 2 different values that the first term could be in this sequence. So we were told that if a term was odd, we'd multiply it by 2 to get the next term. So if the next term was 86, we would have some n times 2 is equal to 86. So n is equal to 86 divided by 2, which is 43. So that's one possible term. That was if it was an odd number. Now, if we were told it was an even number, so we'll say that it was an even number, we were told to add 2 to it and half your answer to get it. So we were told that 86 is equal to n plus 2 divided by 2. Is going to be 172 is equal to n plus 2 because we're cross multiplying. So it's going to be 172 minus 2 is equal to n. 170 is equal to this value. So it could be 170 also. So that is the answer to that. So a different sequence following the same rule. So we're still using this rule up here. Starts with the number k, which is an odd number. So we know that k is an odd number. So if it was an odd number, we need to multiply it by 2k to get the next term. So our next term is going to be 2k because we know this is odd. So our next term is going to be 2k. Now, if we multiply 2 by anything, we're always going to have an even number because 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, etc., etc. So if we, no matter what, it's going to be an even number. So this is going to be an even number. So that's our second term. And our third term then, because we have an even number, if we add to it, so it's going to be 2k plus 2 divided by 2. So that's our equation, which means that's effectively is that's going to cancel with all these. So it's going to be k plus 1. Now we knew that k was an odd number, so if we had 1 and we added 1, 2, it would be 2. If we had 3 added 1, 2, it would be 4. So no matter what, if we add 1, 2, k, it's going to be an even number. So this is going to be an even number also. So it's going to be k plus 1. And using this equation again, so it's going to be k plus 1 plus 2 over 2. So I've taken that bit out, I've added 2 to it, and I divided by 2. So it's going to be k plus 3 over 2. And that's it. We don't need to figure out whether that's odd or even. Okay, good. So we'll move on to the next one. So coming to this, number 10, we draw each of the following two functions on the domain. So we have a function y is equal to 10x minus 4x squared, and we're told that it falls between the domain minus 2x and 2. So the easiest thing here is basically just to sub in values. So we know that this is what the function. So we're told that y is equal to that. Remember what I said earlier on, f of x is essentially equal to y. So we're going to do that. We're going to say f of x is equal to 10x minus 4x squared. And I'm going to now sub in values of x between this. So I'll get f of minus 2 is equal to minus 20. And that's going to be minus 2 squared is going to be 4 because the minuses are going to cancel. 4 by 4 is 16 and then minus. So it's going to be minus 16. That's going to be minus 36. F of minus 1 is going to be 10 times minus 1 is minus 10. Minus 1 to be squared is going to be 1, and minus 4 is going to be, so minus 1 to be squared is 1, multiplied by 4 is 4, and then a minus, so it's going to be minus 4, so it's going to be minus 16. F of 0 is just going to be 0 because the 10 times 0 is 0, and minus 4x squared with 0 is going to be 0. F of 1 is going to be 10. That's going to be minus 4, so it's going to be equal to 6. And f of 2 is going to be 20. And it's going to be, so it's going to be 2 to be squared is 4. 4 by 4 is 16. Minus 16, so it's going to be 20 minus 16, so it's going to be 4. So then drawing that, we're going to have minus 36 for this point here, so it's like roughly there. Minus 16 for this one, so it's going to be roughly here. 0 is going to be at 0. At 1, our y value is going to be 6. And at 2, our y value is going to be 4. So it's going to be roughly this. So our equation or our graph goes something like that. Because it goes up and then slightly goes down again. So then we have to do the same thing for over here. So f of x is equal to 3 of x, 3 to the power of x. So it's going to be f of minus 2 is going to be 3 to the minus 2, which is the same as, so when you have a minus power, it means that the power is below the line. So it's going to be 1 over 3 squared, which is equal to 1 over 9. F to the minus 1 is going to be minus 3, or sorry, not minus 3. It's going to be 3 to the minus 1, which is equal to 1 over 3 to the power of 1, which is equal to a third. F of 0 is going to be 3 to the power of 0, which is equal to 1. F of 2 is equal to 3 squared, or sorry, f of 1 first, is equal to 3 to the power of 1, which is just 3. And f of 2 is equal to 3 squared, which is equal to 9. So then you just basically sub them in. So at minus 2, so our x is minus 2, our value is going to be a 9, so it's almost going to be here. When f is minus 1, our value is going to be basically here, because it's going to be a third. At f of 0, so when x is 0, our y value is going to be 1. When x is 1, our y value is going to be 3. And when x is 2, our y value is going to be 9. So we're going to have a graph like this. So that's that. Solve the following equation. Give your answer in the form of m over n. So to do this, you basically factorize one side and then let it equal to each other. Or so I get a lowest common denominator on one side and then let it equal to each other. So with our lowest common denominator here, we can say is 2 times 3. And then it's going to be 3 times 3x plus 5 plus 2 times x minus 4 is all equal to 16. So that's going to be 9x plus 15 plus 2x minus 8 all over 6 is equal to 16 over 1. And then you cross multiply them. So I'll just do this part first. It's going to be 11x plus 7 is equal to, and 16 times 6 is going to be 96. And then that 7 is going to come across. It's going to be 11x, 96 minus 7. That's going to be x is equal to 89 over 11. So 96 minus 7 is 89, and then dividing both sides by 11. So if you can imagine that side was divided, this was divided by 11. So x is equal to 80. X is equal to 89 divided by 11. That's that question done. Factorize. So these questions come up quite a bit. So it's just very important that you know how to do these. They're pretty simple as long as you know what to do. If you want to think about a different way, it would be like a x squared minus b y squared, where this is where this can be a square root basically can be found, and it basically becomes ax minus by ax plus by, and there's not an awful lot more to them. So as long as you can identify them and work them out, they're pretty simple. So this is going to be a minus 4n, a plus 4n, and that's your answer. Nothing else to it. So one of the factors of this is x plus 6. So we're told that one of the factors is this. So if I divide that into this, I should find the other factor. So x plus 6 divided by 8x squared plus 45x minus 18. So I'm going to multiply that by 8x. 8x squared plus 48x. So that's going to be a minus. It's going to be a minus. That's going to go to 0. That's going to go to minus 3x. And that minus 18 is going to come down. So it's going to be minus. And then that's minus 18. So it's going to be minus 3, minus 3x, minus 18. So 8x minus 3 is another factor. So the factorizing it is x plus 6 multiplied by 8x minus 3 is the factors of that. And that's the answer done. Write down one quadratic expression in x other than this that has a factor of x plus 6. So it just basically means write down a quadratic expression in x other than that. So, and it says give your answer on that. So we'll say x plus 6. Well, I know that I'll just put in some other factors. So I'll just call it x plus 1. And it's going to give me x squared plus that's x, and then so it's that by that, and then this by this. It's going to be 6x plus 6, x squared plus 7x plus 6, and then it's asked me to give in this, so that's in the form of, so that would be ax squared plus bx plus c. So this will be your equation. You could have picked anything for this. You could pick 2x plus 7, anything you wanted. X plus 1 is obviously the easiest one to do that. Show that this is a factor of this. This is pretty much the same thing as you've been asked to do here, but it's obviously asked you to do it again, kind of. So it's 2y plus 3, 2y cubed minus 9y squared. Again, if this divides in easily, we know that it is a factor. So that is just going to be y squared. So 2y cubed plus 3y squared. And then that's going to be a minus, that's going to be minus, that's going to be minus 12y squared minus 28y. So that's going to be minus 6y. So minus 12y squared minus 18y. That's going to become a plus. That's going to become a plus. That's going to go to 0. They went to 0 as well. So that's going to be minus 10y minus 15. And that's going to be a minus 5. So that's going to give you minus 10y minus 15. So this is a factor. And that's your answer for that. Done. Okay, 13 then. Frida is starting an exercise program. She wanted to increase her power output P. One formula for P is equal to 36W plus 62H plus 1800, where W is Frida's weight in kilometers and H is the height in meters that she can jump. So we're just given some equation for P, and this is the equation that she has. And basically it says work out the value of P when W is 70 and H is 0.65. So for the first one, we're simply just going to work it out by subbing in those numbers. So we have P is equal to 36 times 70 plus 62 times 0.65 plus 1800. And that's going to go to 2520. That's going to be 40.3. And that's going to be 1800. So P is equal to this. And P then is going to be 4360. 4360. 0.3. Yeah, that's fine. So after 1 week, Frida's power output has increased by 8. So her power output, whatever that was, is now 4360. So we'll call it P new. 4360.3 plus 8. So it's now equal to 4368.3. work out the new value of H after this week. So H was the height that she could jump. So with her new power, she's obviously able to jump higher. So we use this equation, and we're going to change the value of P. W is going to stay the same at 70, and we need to find H. So it's going to be 4368.3 is equal to, we know this, 36 by 70 is 2520, so we put that in. Plus 62H plus 1800. So we're going to take the things across on one side, so 4368.3 minus 2520 minus 1800 is equal to 62H. So now I'm going to divide both sides by 62 because I want to get rid of that. And this side is all going to be divided by 62. So H is going to be equal to the calculation of this. And that's all going to go to 0.78 meters in the calculator. So it should be pretty easy, but that's basically how you work it out. Okay, the next one, the graph below shows the value of P for different heights when W is 70 kilograms. So we know that the W value is equal to 70 kilograms. The graph cuts the y-axis when P is equal to 4320. So we know that the y-axis is being cut at that value. Draw a graph to show the values of P for different heights H when W is equal to 80 kilograms using the same axis, scales, and domain. Note the axis with P does not start at 0. So it's just showing you some values that it's put in when the height. So if her height when she jumped was 0 meters, that would be her power. As her height gets, as the height she jumps increases, the power is getting more and more. So what we're going to do is we're going to sub in our values for 80 and see where we end up. So we had this equation, P is equal to 36W plus 62H plus 1800. And we're going to assume values for H. So I'll say P is equal to 36 times W plus 62H plus 1800. Now we know that W now is 80 kilograms. So it's 36 times 80 plus 62H plus 1800. So that's going to go to 2880 plus 1800 plus 62H. So we end up with 4680 plus 62H is equal to P. And now what I'm going to do is I'm going to assume values. So it says to me, draw a graph to show the values of P for different heights. So if I said the H was equal to 0.6, well, my P value is now going to be 4717.2. So I've put in a value for H. I've just assumed a value for H, and now I have this value for P. The next one I'm going to do is I'm going to assume a value of H of 0.7. And my P value is now going to be 4723.4. And now I'm going to assume a final one of 0.8. And my P value is now going to be 4729.6. So if I assumed, so it's going to be bigger. So even if I just left it at 0, my value for H was 0, my value would be 4680. So I can assume my 4680, and I just have some value like that at W is equal to 80 kilograms. All right, I hope that's clear. All right, then Frida finds a second formula for power output. She sets the two formula equal. This gives the following identity where F is Frida's height in meters. So 60W plus 80H minus 15W minus 1300 is equal to this new equation, or this equation that we had before. So this is the same as what we had before. So she has a new equation, which she's saying are the same. So she wants us to find H in terms of W and F. So that means that we have to get H on one side. So we're going to leave our H's, bring our H's across and bring everything else to the other side. So we're going to have 80H minus 62H is equal to 36W minus 60W plus 15F plus 1800 plus 1300. So 80H minus 62H is 18H. 36 minus 60 is going to be minus 24W. Plus 15F plus 3100. So then just divide everything by 18. So you're going to get H is equal to minus 24 over 18W plus 15 over 18F plus 3100 over 18. There's no need to break it down any further than that. That's fine. Yep, so that's that done. Hopefully that was pretty clear too. So basically you had an equation, you're trying to separate it, get everything in terms of H, so you bring them all across and you want to have H on its own. So this wouldn't quite be correct because it's asking you to write your answer H in terms of everything else. So that's 13. So then the last one is going to be question 14. So it says the first three terms of a sequence are these values. So the first term is term 2 minus term 1. So we have three terms in the sequence, term 1, term 2, term 3. Fill in the following table to write each of the first differences in its simplest form in terms of x. So the first difference is term 2 minus term 1. So we're going to be left with x squared minus 2x minus 6x plus 3. So that's x squared minus 8x plus 3. So that's our first difference. Our second difference, or our first difference for 2 is term 3 minus term 2. So 4x squared plus 3x minus x squared minus 2x. So it's going to be 4x squared plus 3x minus x squared plus 2x. So that's going to be 3x squared plus 5x. And that's done. Yeah, nothing else to it. All right, show that in terms of show that if the terms form a linear sequence, then 2x squared plus 3x minus 13. So to form a linear sequence, we're going to let them equal to each other. So bring them all onto one side. We have a plus 2x here, so I'm going to bring them onto this side. So I'm going to bring everything from here to here. So it's going to be 3x squared minus x squared plus 5x plus 8x minus 3 is equal to 0. 2x squared plus 13x minus 3 is equal to 0. That is equal to that, so we're good. Solve the equation 2x squared minus 3. Give your answer correct at 3 places of decimal. So, I mean, very quickly we know that it's not just going to factorize very simply because we're told it has to be done to 3 places of decimal. So we know that we probably need to use our equation minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's our a value. So a is equal to 2, b is equal to 13. I shouldn't have done that probably. b is equal to 13 and c is going to be equal to minus 3. So subbing those values back in, so minus b is going to be minus 13 plus or minus 13 to be squared is going to be 169 minus 4, I'll put them in, 4, A is 2, and C is minus 3, all over 2 times 2. So that was 13 to be squared. I just did it very quickly. So that is going to be minus 13 plus or minus the square root of, so 4 by 2 is 8, by 3 is 24, and a minus is going to be a plus. So it's going to be 169 plus 24 all over 4. So that's going to equal minus 13 plus or minus the square root of 193 all over 4. And you're going to get 2 versions of this. You're going to get a plus version, you're going to get a minus version, and your answers are basically going to be minus 6.723 and 0.223. So you get 2 values of x, and that's it. I hope that was pretty clear. Yep, so that's it. Thank you very much for your time. I have a Facebook page, More Learning Limited, where I will be publishing many answers to the Irish Leaving and Junior Cert papers over the next few weeks. So stay tuned, and if you subscribe to it, you should find some videos which are relevant to you. It's More Learning Limited on Facebook. Thank you very much for your time.